Going on, guys. Let's do this problem right here. The question is asking, an architect want to build a wall with the profile shown. To estimate the effect to wind loads, he must determine the wall's area and the coordinates of the centroid. So what are they? So they're basically asking for the centroid of this picture, and let's see how we can find it. So first of all, in this kind of question, what we do is so the equation of the curve is given right here. So what we do is we cut a part of this and create equation based on that. So let's do this one. So first of all, this is going to, since this is a rectangle, the center is going to be exactly in the middle. It's going to be somewhere here, and then this is going to be my dx, and this is going to be my y distance, and this is x. So that's all about it, and then we can create set of equation based on that, but our purpose is to find x bar and the y bar. So equation of this one is going to be integral of xdA divided by integral of dA to find the x bar. To find the y bar, I had to calculate integral of yda divided by integral of dA. So that's how it's done. So let's see how we can find these values. So first of all, I have to create an equation for dA, so area. So differential equations area is going to be dA is equal to 2 point this equation given right here, so I use that one. So 2 plus 0.02 x square multiplied by dx. So this is the equation, differential equation for dx. So let's integrate this one and find the area. So in this case, if I integrate this one, so integral dA equal to integral, the total distance is 10, so 0 to 10. Then I put the value right here, so it's going to be 2 plus 0.02 x square dx. So in this case, if I integrate this one, it's going to be 2x plus 0.02 x cubed divided by 3, and this is 0 to 10. Then if I integrate, that will give the area right here, and this value we have calculated already integral of this one. Now we simply substitute the 10 and get the area. So if I substitute 10, it's going to be 2 times 10 plus 0.02 10 cube over 3, and if you calculate this value, that comes out to be 26.6 meters square. So this is my area. Now I have to calculate this xdA. So we are doing x first. So in this case, what's going to happen is xdA, so I do the same approach. So it's going to be integral of xdA, it's going to be equal to 0 to 10 x multiplied by the same this area equation. So it's going to be 2 plus 0.02 x square dx, and if I integrate this value, that comes out to be 2x square divided by 2 plus 0.02 x4 divided by 4, and this is 0 to 10. So in this case, now I substitute this 10 for the x value, and let's see what we get right here. So it's going to be 10 square, because these 2 cancels each other, so 10 square, and 0.02 times 10 to the power of 4 divided by 4, and if you find the value, that gives us 150 meter cube. So we have the area and we have integral of xdA. Now we can simply substitute both of them in this first equation. So if I substitute, it's going to become 150 meter cube over 26.6 meters square. That gives us the value uh, 5.625. So this is my x bar. So we found the x bar. Now we have to find the y bar. So to find the y bar, I have to create another equation. So in this case, y bar is going to be equal to since the line is this line is half of this, so y, they have given the equation 2 plus 0.2 x squared for the full line. For half of the line, it's going to be divided by 2. So let's do that. So it's going to be 2 plus 0.02 x squared divided by 2, because we are taking the centroid, so y is this distance, that's why divided by 2. Then if I take the area equation, it's going to be same thing. So dA is going to be equal to 2 plus 0.02 x squared dx, and then if I integrate y dA, so that's what we have to find. So y bottom we already found, so we don't have to calculate again. The top one I'm doing this. So let's separate this one. Maybe I choose a different color to avoid confusion. So okay, so integral of y dA, that's going to give us half time integral of 2 plus 2 plus 0.02 x square. So I'm applying the y here. Then I multiply this one by dA. dA is going to be the same equation as this one, so it's going to be 2 plus 0.02 x square multiplied by dx. So in this case, so I'm integrating this 10 to 0. So if I integrate, I will get the value that gives us. So first of all, let's simplify this one even more. So if I simplify integral by dA, that gives us half, and here it's going to be 2 times 0.2 x square, and if I expand, if I multiply both of them, I will get 4 plus 0.08 x square plus 0.0004 x power 4 times dx. So if you integrate this value, it comes out to be half times 4x plus 0.08 x cubed over 3 plus 0.004 x power 5 divided by 5, and this is 0 to 10. Then we simply substitute the 10 for this x, and if you substitute, you will get the value. Let's give you 37.3 meter cube. Now we have the integral of yda, and we know the integral of dA already, so we can simply substitute this one into this equation. So if I substitute, I will get 37.3 divided by 26.6 meters square. So this is meter cube, this is meter square, so the final answer is going to be in the meter, and if I divide both of them, I will get 1.40 meter. So this is my final answer, and this is my centroid. This is where the centroid is going to be. So let's see in the diagram where exactly it is. So in this case, if you look at the diagram, so x bar is going to be 5.625, right? So 5.625 mean this is, we know this is going to be 5. 5.625 mean exactly somewhere right here. So somewhere right here, and the height is y bar. Y bar is 1.40. So this is 1, and 1.40 mean exactly somewhere right here. So if you expand this line, it's going to give you the centroid, so it's probably somewhere here. So this is the centroid. So this is how we find the centroid, and that's all about it. I hope you guys like this video. See you next time.